Alternatively, if the customer chooses our selective laser sintering process, we would prepare their geometry and send it to the SLS machine. Our process engineer, Matt McLean, will show you how the SLS process works.
This is the program that we use to set all the builds up. Each one of these particular parts is a STL file, the same as everything else. The big difference in the SLS process versus the SLA is that these parts don't have supports at all. They build in an entire cake of powder. There's a layer of powder that supports them underneath, so you don't actually have support since it's not a liquid. The other thing about this is you'll see in the SL parts, we only nest things within the X and Y footprint. With this process, we can actually stack stuff on top of each other and nest parts completely inside of other parts to get, you know, a totally different approach to how things are done. These parts, in order to get them all in one build, I kind of had to stick this part into the middle of this other one here. So you can see we put everything on odd angles to get, you know, certain features to show up better, and different properties of individual parts. This unit right here is the RCM. We call this a rapid change module. This is the actual piston that the parts build in. So what you're seeing here is a four-sided box or five-sided box. The whole thing is heated around here. So as it moves down, this piston will actually index down and parts build inside of this chamber. The entire RCM and the surface of the powder itself is heated up to about 370 degrees, which is just a few degrees away from the melting point of the plastic itself. So when the laser actually centers a particular area, it only uses just a minimal amount of energy to kick that solid part over into a liquid and then recrystallize back into an actual part. So the whole machine, basically everything on there, is heated up to better than 300 degrees. This is an infrared laser. It's much hotter. This one is only applying a heat to the part. It's not actually curing with UV light. It's actually sintering, melting the plastic into a solid part. So you won't see the laser. It's just applying heat to it. But you can see where it turns from kind of a gray to a shinier black color, where it's actually scanning the parts. Once the build is completed inside of the machine, we'll roll this whole RCM out of it, cap it off, and let it cool down for a specific amount of time until the parts are cool enough that we can handle them and break them out and start using them. So now we're actually going to bring the piston up, raise it all the way up, and start pulling the parts out of the block of powder here. You can see this is relatively stiff cake, but there's plenty of parts inside of this. It's very archaeological in nature. I mean, it's kind of it's almost like going into a dig, you know, where you know there's stuff in there, you're not 100% sure where it is, and you kind of got to be a little delicate when you're getting them out of there, because they're still relatively warm right now. We're looking at probably 150 or so degrees for some of these parts. So okay. Typically we run cool down times about as long as the build. You know, so if we do a 20-hour build, we'll typically do at least 20 hours to cool down. Right, so this will go into this area right here, go through a sifter to sort out the big chunks that we can't use, and get recycled back into another machine that will, you know, blend it with a certain amount of new powder and recycle all that back into the machine. This will actually take a specific ratio of used powder and the virgin powder in these two larger bins, mix that together to form our actual build material in the smaller bin in the front. This whole machine basically just takes those two, keeps them blended, keeps everything well mixed, and we'll pump it to the machine whenever the machine needs it to start building. Okay. This is the bead blast chamber. This is once the parts have come out of the machine and cooled off and been broken out of the cake. We'll run them through here, manually bead blast them. It's just a real light glass media that'll blast off the little bits and pieces of powder that are stuck to the parts, really clean up the outside of them pretty well. No supports to remove, no sanding. They're basically, that's pretty much all there is to them.